Alrighty, guys. So the one we are looking at is this one right over here, number 28. It's talking about finding the distance between two cities, and you will see your latitude, of course, is given to us in the degree, minute, second measurement. So they're telling us find the distance between the cities. Assume that Earth is a sphere of radius 4,000 miles and that the cities are on the same longitude, which means one city is going to be due north of the other. Round your answer to the nearest mile. So the distance we're finding is between San Francisco and Seattle. You can see the latitudes for both of them. San Francisco is 37 degrees, 47 minutes, 36 seconds. Seattle is 47 degrees, 37 minutes, 18 seconds. So basically you're treating this like you're finding the arc length. So you're finding that S equals R times theta formula for the arc length. That's what you're using. And basically the idea is we need to figure out what the R and theta is going to be so we can find the S value. So let's take a look at this guy here. So this is going to be S equals R times theta. Alrighty. What do you think the radius is going to be? Yeah, they're giving that to you, right? The 4,000 miles. So that's going to be our radius. So now for the theta, what do you think we need to do? You will eventually, but before we convert it to radians, which I guess technically you could convert it to radians first and then do the other calculation, but I think it may be easier. Because we got to find what's the difference between the two cities, right? Find that angle. So you want to go ahead and subtract those two angle measurements. So like I said, you can convert it to radians first and then do the subtraction, or you can do the subtraction first, then convert it to radian. So let's do subtraction. What do you think that will come out to be? So we're taking, let's see, the larger one would be 47, 37, 18, and then the smaller one would be 37, 47, and 36. So what will that difference be between the two? And again, if you guys have calculators, you can plug this in. You have one? Like I said, one of my calculators is missing. I'm not sure what happened. Maybe one of the other professors has it, who knows? What's the difference going to be between the two angle measurements?
I got 9 degrees, 49 minutes and 42 seconds.
9, 49, 42. Okay, let's see if we can get Desmos here. I am actually not sure where the symbols are in Desmos. Interesting. All right, tell me that again, 9 degrees, you said?
9 degrees, 49
Minutes.
minutes and 42 seconds.
49 minutes and 42 seconds, okay. Let's convert that into radians. This is so weird, why does this not give us all the options? Now, again, you can use a calculator to convert this into radians, or you can use, well, if you wanted to do this by hand, then of course you would first have to convert this into the degree decimal form, because obviously we cannot leave it with minutes and seconds, and then you would have to convert it by using pi over 180 to convert it then from degree to radians. I am really stumped by Desmos, kind of disappointed that I'm not seeing what I need to see. Let's see if the calculator itself has something here. But it's not giving us the minutes or seconds either. Okay. All right, what did you guys get for radians? Now, on these calculators, I did figure out how to convert them from DMS to a decimal form. You have to use the second key and then the DRG key at the bottom for the school calculator. So if you type in the 9 degrees, 49 minutes and 42 seconds, basically you will be using the DMS key. So you will, remember how with these calculators just gives you the degree symbols after each one of them. So type that in and then use the shift key. And then at the bottom near the equal to sign, you have the DRG key. If you press on that, it convert, and you'll select degree, of course, which I believe is option 1. When you do that, it should convert that into the decimal degree option. And if you do 2, which is for the radians, it should convert that to the radian option. So what will it come out to be?
563.12 is,
In radians?
yeah, that's what I thought.
No. So back to scientific, we have 9 plus we are doing 49 and 60. Oh, no, 1 over 60 is plus 49 over 60 plus 42 over 3600. Okay, so this should be in the decimal form of degrees. We have 9.828. 333 repeating, and this will be in degrees, and now you want to convert this into radians. Let's copy that, and we'll see if we can get this from our finger measurement here, so in. Point 828,333 repeating, and this is what you should have in radians. 0.17153, whatever else those numbers are. And I'm actually going to leave that on my calculator, because then we can use that for our calculation with our arc length. So now that you have your radius, which of course we already had that at 4,000 miles, you have your angle in radians, 0.17153677665. Keeping all those decimals, you should just be able to multiply those numbers, and it should give you your arc length. You can use the pi times 180, pi divided by 180 factor also to convert your degree into radians, and then multiply this number by 4,000. And that's going to be your arc length. $686.14710. And this will be in miles, since your radius is also in miles. They're asking you to round this to the nearest mile. So since you have a 0.1, this will of course round to 686. And let's check that. There you go. So basic arc length calculation is what you are looking at over here, but you just have to figure out what that angle is going to be between the two cities. And then of course they're giving you the radius, because you are still treating this as a circular shape, right? They're telling you specifically, think of the earth as a sphere. And then you have your radius of 4,000 miles. Questions on this one, guys?
No, but I do have a question about number 26.
This one?
Yes.
Okay, they're asking you to find the radian measure of the central angle. What formula will be used for this guy? Because obviously they're asking you to find this angle over here. What formula do we use? What is the information given to you? What does the 70 and the 49 represent?
Radius and arc length.
Very nice. They're giving you the radius. They're giving you the arc length. They're asking you to find theta. So again, what formula are you using here?
Theta is equal to S divided by radius.
Yeah, it's actually the same formula we just looked at. You're just solving it for theta. So divide S by R, and you have your theta, which in this case, our S is 49, R is 70, and what will that come out to be? 0 point something, right? 0.7. And remember, by default, this will be in radians. So let's see what this guy says. Six. Hey, what happened? Find the radian measure of the central angle. This is by default in radian, 49/70. That's what we did is 0.7. Thank you. I was not paying attention to that. Yes, because you are going in the what direction? You're going in the clockwise direction. It is going to be a negative angle. Thank you. Let's try that. Number 26. There we go. Alrighty, thank you. So let's make sure this is negative. Was that the trouble you were having?
Yeah.
Yeah. So was it just the negative you were leaving out, or were you having trouble with the calculation?
It was like the formula I had to use.
Okay, do you remember what formula you were trying to use?
No. It was just different.
Okay, so basically you have to see what information is given to you. And then based on that, you would have to then decide which formula would work the best. And at this point, we haven't really seen that many, so it's only a few you are choosing from. So yeah, just narrow it down from looking at what information is available and which formula would help you. Okay. All righty, folks, let's get back to our handout. So we had just started talking about trig functions and unit circle. So let's get back to that one. Alrighty, so remember your 6 main functions, which the 3, I guess, main of the main functions would be your sine, cosine, and tangent. And then their reciprocal functions. For sine is cosecant, for cosine it's secant, and for tangent it's cotangent. And then we had also talked about how, depending on, the way the definition is given to you, depending on what is on the denominator. So if you have y values on the denominator or x values on the denominator, for certain angles, they are going to be undefined, because again, you still cannot divide by 0, just like we talk about that in algebra. So those would basically be at your 0 degrees, pi halves, pi, 3 pi halves, and then of course, as you go into rotation, it will still be the same. So either secant, cosecant, tangent, or cotangent, they'll be undefined depending on which value falls on the denominator. Then we also talked about how you can use, the idea of the x and y coordinates for each of the points on the unit circle. So basically, whatever angles you have, for each angle measurement on the unit circle, it will also correspond to an x and y coordinate. And you can kind of see that over here, because these guys are making 45-degree angles over here. So if you think of this as the initial side, this is actually making a 45-degree angle, and it keeps doing that. So each one of these in one form or the other represents 45-degree angle or rotations of it. And you can see they correspond to square root of 2/2 for your x and y coordinates. And then depending on which quadrant it falls into, they may be positive or negative values. Same thing they are showing you over here if we divide the unit circle into 12 equal arcs. So again, starting from the initial side, you can see this is arc 1, arc 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by the time you come back. So if you are dividing it into 12 equal arcs, what do you think that angle measurement is going to be? So like this one over here, that very first angle between the initial side and that very first division that we're making. Think about 360 being divided into 12 equal parts. What angle measurement are we looking at?
30.
Yeah, so each one of these are measurement of 30 degrees. And you can see for that, it corresponds to square root of 3/2, and 1/2 for your X and Y coordinates. And then of course, as you move along the circle, you will see those values are going to, keep changing what those ordered pairs are going to be. So they're talking about, how you can actually come up with some of these measurements. Now, we're not actually going to get a whole lot of detail into this, but I did kind of walk you through this. So they're talking about to verify the points on the unit circle, and this was for that 45-degree angle. It lies on the line y equals x. So if you're talking about this line over here, this line represents y equals x. So remember, that's a line with a slope of 1, right? And its y-intercept is at the origin at 0, 0. So this is your y equals x line. And this one would, of course, then represent y equals negative x, right? So they're basically saying, if you use this idea of that these 2 points are falling on the line y equals x, using that concept, plugging it into our equation for a circle. Remember, the equation of the circle is x squared plus y squared equals 1. If your line represents y equals x, we can actually replace our y square with x squared. So basically they're saying if y equals x, then instead of using x squared plus y squared equals 1, we can replace that y squared with basically x squared using that, and then simplify that, and you can see that comes out to be x squared plus x squared will add up to 2x squared. Divide both sides by 2. And you can see that ends up giving you x squared equals 1/2. And then since this is a square, we end up taking a square root, which gives us 1 positive and 1 negative root. Rationalize your denominator, and it comes out to be square root of 2/2 with the plus and minus sign. So they're using simple algebra just to show you how you can come up with these x and y coordinates on your unit circle. So remember, in this case, again, since x and y are equal to each other, both your x and y coordinates have the same value. So you end up getting x squared, x and y both equal to square root of 2/2. And then remember, as I said, depending on which quadrant you are in, your x and y values may be positive or negative depending on the quadrant. They're saying you can use similar kind of reasoning. Let's clear this out. You can use similar kind of reasoning for, breaking up our equation into 12 equal parts. I mean, our unit circle into 12 equal parts. So that's kind of where, your algebra is tying in back into trigonometry over here. So we're saying basically using the coordinates from our 2 figures that we looked at, you can evaluate the trigonometric functions for these common t values. Now remember, your t values are those angles on the unit circle. Examples 1 and 2 demonstrate this process. We'll take a look at that. You should study and learn these exact function values for t values, because like I said, we'll be using that unit circle. So that's kind of what this is tying into. So let's take a look at how they came up with some of these. So for the first part, your t is given to you as pi/6. So how can we come up with the value of the x and y coordinate for pi/6? So this is something that we should talk about at this point, is when we're talking about these coordinates for x and y, they actually start representing those trig functions we were talking about. So the x coordinate actually represents your cosine function at that value of t, and your y coordinate represents the sine function. So think about alphabetical order. C, of course, comes before S, just like X comes before Y. So that's how we set up that ordered pair. That's the same way. So cosine is always going to be the first coordinate. Sine is always going to be the second coordinate. So the X value will represent cosine. The Y value will represent sine. So basically we are saying now to see again for pi over 6, what does this come out to be? They are actually using kind of falling back to geometry at this point. They're using the 30, 60, 90 degree triangle, where of course, you know, the largest angle is going to be your 90 degrees. One of the angles is 30, the other one is 60. So they're using the ratio of this triangle where one is going to be the smallest value. So that goes across from the smallest angle. 2 is going to be the largest value, which goes across from the largest angle. And square root of 3 is approximately what? What's the decimal approximation for square root of 3?
25-ish.
Yeah, it's actually at 1.7. So even though you may think it's 3, it's actually square root of 3, which makes it a number smaller than 2. So that's why that guy goes across from the center, middle angle. So the smallest measurement goes across from the smallest angle. The largest measurement goes across from the largest angle. And then, of course, the middle one will go with the central, the angle which is in the middle. This is actually something we will be talking about a little bit more later on. Right now, we're just kind of introducing or reviewing in a way, because this is something I'm hoping you guys have studied in your earlier math career. But basically 30, 60, 90 is one of the more common triangles we use. An isosceles triangle with 2 angles, which will be 45 degrees and a 90-degree angle, is the other one that we use. So these kind of ratios help you come up with these values for your T, angles also. So using this idea, you can basically see if we are talking about pi over 6, that is the same angle as 30 degrees. Yeah, 30 degrees. So you are basically using this idea of trying to see if we have that here. Looks like we do. These are the definitions we actually go forward with when we're talking about these 6 angles. So let's actually get back up to the top. So you can already see how these functions are defined. You of course have sine of t equals to y, which of course corresponds to your x and y value over here. So you can see your sine of t is already the y value. Your cosine of t is the x value. Your tangent is defined as y over x, which can also be defined as sine of t over cosine of t. Because remember, y represents the sine function, x represents the cosine function. So you can actually write this as sine over cosine. Now, since these guys are reciprocal functions, the cosecant, you can actually write cosecant as 1 over sine function also. You can write the secant, which is the reciprocal for the cosine function. So you can write it as 1 over cosine of t. And then your cotangent, being a reciprocal of the tangent function, you can actually write it as cosine of t over sine of t. So just alternative definitions for these functions. And then using our little triangle concept that I was talking about, these are some of the other definitions that will come in handy. Trying to see if I have them listed out here. Doesn't look like it. Yeah, I think this is the one. And these handouts again, guys, are available to you in D2L. So this is a supplement handout that might help you kind of work through some of these, just initial definitions over here. So again, we're basically taking a triangle and superimpose it on top of a coordinate plane. So you can see this is your x-axis, this here is your y-axis. And basically your central angle theta going in the counterclockwise direction. So this distance over here is next to the central angle. So that is the side that we call as the adjacent side. So this X where you have that would be the adjacent side to your central angle. Y, on the other hand, you can see is across from the central angle. So that is what we call as the opposite side. And then, of course, you have your 90-degree angle over here. So side across from 90 degrees. And this you should know from your Pythagorean theorem is your hypotenuse, right? So you have the adjacent side, which is next to the angle, the opposite side, which is across from it. And then, of course, the hypotenuse is the side across from the 90-degree angle. So when we define our little definitions over here, when you're using right triangle trigonometry, basically we use this concept of adjacent, opposite, and hypotenuse to define our 6 functions over here. So you will see we define the sine function as opposite over hypotenuse. So this is sine opposite hypotenuse. So that's your SOH. Your cosine function is defined as adjacent over the hypotenuse. So that is CAH. And then your tangent, of course, is defined as opposite over adjacent, because again, remember, tangent is sine over cosine. So sine represents the opposite side, cosine represents the adjacent side. So this becomes TOA. And this is, one of those, like, please excuse my dear and Sally things. The SOHCAHTOA helps you remember the order of the function. So SOH is sine opposite over hypotenuse. Ka is CAH, so that's cosine adjacent over hypotenuse, and TOA is tangent opposite over adjacent. So it helps you remember those definitions. And then basically replace that, reverse the order of the functions when you're looking at the reversible or the reciprocal functions. So cosecant will, of course, then instead of being opposite over hypotenuse, will become hypotenuse over opposite. Secant would be hypotenuse over adjacent, and then, of course, cotangent is adjacent over opposite. There's not really anything to help you remember, but if you can remember the 3 main functions, then just reverse those, and you get your reciprocal functions. The other thing, if you remember, that I had asked you to kind of recall was because sine starts with an S, its reciprocal starts with, and actually that should say reciprocal. So the reciprocal of sine would begin with a C. So that's going to be cosecant. Remember, cosine is the main function. So that's not the reciprocal. It's got to be cosecant. For cosine, its reciprocal is going to be secant. And then, of course, tangent is the easiest one because its reciprocal is going to be cotangent. So this one just gives you a very brief summary to kind of remember, just how you use these right triangle definitions to help you out. You've got some examples here if you guys wanted to practice. And like I said, this is all available to you in D2L. This is not for a homework grade, but if you guys just wanted to practice some of those so you can get comfortable with the definitions, you can definitely do that. All right, let's get back. So using that definition is where they're coming up with these sine and cosine values for the pi over 6. So you can see now, because for the sine function, we talk about opposite over adjacent. So it's a sine of t, which in this case, your t value is pi over 6, would be opposite, which is 1, over hypotenuse, which would be 2. And you can see that's where that 1/2 is coming from. For the cosine function, so in this case, our cosine would also be the same angle, pi over 6. That would be adjacent, so that's square root of 3 over hypotenuse, which would be 2. And that's where that definition of square root of 3 over 2 is coming from. So using that idea of SOHCAHTOA, using the right triangle trigonometry is how you are coming up with these definitions over here. If we had to do tangent, you would first have to find your sine and cosine and do it that way. But again, if you were doing it with the triangle, then just to show you with the triangle, I'm kind of running out of space here. Tangent is TOA. So tangent of pi over 6 would then come out to be, let's see, that's opposite, which is 1 over adjacent, which is square root of 3, which then you would have to rationalize. And that should come out to be square root of 3 over 3. And then, of course, you can find the other three functions by inverting those fractions. So that's basically what your right triangle trigonometry does. If you can come up with, like I said, the 30, 60, 90 are the most common ones. And then the isosceles triangle with 245-degree angles would be the other one, which would kind of get you there. Let's see, what other angles did we have? And they're kind of listing all 6 of those functions over here. Your next one was 5 pi over 4. So you can see when we take the 5 pi over 4, convert it to a degree measurement, it comes out to be 225, which of course places it in the 3rd quadrant. But you will see if you just take the angle from that 180-degree side, it comes out to be a 45-degree angle also. So basically what you can do is subtract that half a circle from it, that 180 degrees, and you end up getting 45 degrees as your reference angle. And then in that case, we can easily find out what its X and Y coordinates are going to be, because now, since we know it's a 45-degree angle, as I mentioned, we can use that isosceles right triangle. So you have 90 degrees over here. These two angles will automatically become 45 degrees, and the ratio for an isosceles right triangle is 1, 1, and square root of 2. Now, square root of 2 is approximately what, 1.4 something? So, it's going to be a number larger than 1. So that's why the square root of 2 goes across from the hypotenuse, which is your largest side. So the two sides where you have the two similar angles will, of course, be the same measurement. And then your largest side will be across from your largest angle, the 90-degree angle. So now, when you wanted to find your sine and cosine for this, again, using this idea of opposite over hypotenuse, you can again see if this was our central angle, opposite would be 1, hypotenuse would be square root of 2, which would come out to be 1 over square root of 2, rationalize your denominator, which becomes square root of 2 over 2. Can you tell me why this angle is negative, or this value is negative? Because you were in quadrant 3, right? In quadrant 3, what's your X and Y coordinates? When you put your ordered pairs, what signs do you put on X and Y values? Is Y positive? Y is also negative, right? Because Y is also in the second bottom half, right? Quadrant 3. So you can see both your X and Y values are going to be negative, which means your sine and cosine values are going to be negative. So you will see both of these are negative answers. Now for your cosine, of course, you will be doing adjacent over hypotenuse. So adjacent is also 1, hypotenuse is 2, and you're still going to end up with negative square root of 2 over 2. Okay, which is actually, if you go back to that first unit circle we looked at, this is basically that 225-degree angle that we're looking at. And look at all the X and Y values. That's 45-degree angle in each of the quadrants. The only things that's changing is the positive, negative sign, right? The numbers are the same, because that's what happens with a right isosceles triangle with that 45-degree angle. So this one here is just showing you how we came up with those numbers. And then again, they're listing all the 6 functions based on that. You will see, since my sine and cosine values are the same, my tangent just comes out to be 1, because you're dividing the same number by itself. Your tangent will come out to be 1. So you've got a couple more examples over here. This one is talking about pi. So think about where pi falls on the unit circle, which is at that 180-degree angle. So basically, that one is going to correspond to the ordered pair -1, 0, because it kind of falls on the negative side of the x-axis, right? So it's really not into any quadrants, it's just on that negative side. So your x value is going to be -1, which is going to be sine. Your y value is going to be 0, which is actually going to be your cosine. Did I say that? No, I said it the other way around, didn't I? Y is the sine function. Yeah, y is the sine function, which is going to be 0. Cosine is the x function, which is -1. 0 divided by -1 is okay because you get 0, but when you divide -1 by 0, you're going to get undefined. So your cotangent is going to be undefined at that pi angle. And then you can see the same thing happens with cosecant because again, your y is on the denominator. So cosecant and cotangent are both going to be undefined. At pi, all the other remaining 4 are definitely, as you can see, they show up. The last one they had was -pi/3. So as you can imagine, since that is a negative angle, we are going in the clockwise direction in this case. And -pi/3 basically comes out to be a 60-degree angle. So you can fall back to the 30, 60, 90 triangle. This will be 60 degrees, your 30 degrees is going to be down here. And then remember the ratio was 1 to 2 to square root of 3. So that means your 1 is going to be across from the smallest angle, 2 is going to be across from the largest angle, and then square root of 3 will be across from the angle in the middle. And then again, just use your opposite over hypotenuse for the sine function. And then we will use adjacent over hypotenuse. The adjacent over hypotenuse for the cosine angle. And then of course, opposite over adjacent for tangent, and then reverse those for your reciprocal angles. So let's pick some examples here because without practice, none of this is going to make sense. Let's see if I can get something from our text. There we go. There we go. So let's pick something from here. And this one, as you can see, is asking us to find sine, cosine, and tangent. But for first couple examples, let's do all 6 of them so you guys can get comfortable practicing. Which ones did we do here? So I don't want to repeat. Pi/3, pi, 5/4, and 5/6. Okay. How about, let's do number 15, -pi/6. So think about in the unit circle, where is that -pi/6 going to fall at? Where would -pi/6 fall at in the unit circle? Very good, 4th quadrant. And what would be the corresponding angle to it that's visible here?
30 degrees. Or 5, 6.
Yeah, because basically just imagine if this guy was reflected down here, right? So your pi/6 reflected down here would be this angle right here. So this would technically become -pi/6. So this is the type of angle we are basically looking at. So, if I were to draw a triangle there, this is kind of what it would end up looking like. So let's transfer this guy over to our example here. Let's see if we can get rid of that. Can you tell me in degrees what negative or just pi over 6 would come out to be?
30 degrees.
30 degrees. So we can basically fall back on our 30, 60, and 90 degree triangle. So remember that ratio is 1 to 2 to square root of 3 for the 30, 60, 90, which these actually should be switched around if we're doing it this way. So 1 will go here, 2 is the largest number, it will go here. So that means square root of 3 will go here. So now remember, this is a quadrant 4 angle. So when you try to find sine of t, and you know what, let's just put the angle. This would be sine of negative pi over 6. What do you think that will come out looking like using your opposite over hypotenuse definition? Remember, this is your central angle that we're looking at. So opposite over hypotenuse, what will that give us? Yeah, because remember, again, from the angle, the opposite side is here. Hypotenuse is always across from the 90-degree angle, and then the one next to it, or kind of, sharing the side with the angle, is the adjacent side.
Would it be negative?
It will be negative, right? Because your sine function corresponds to the y value, and your y value is going to be negative in the fourth quadrant. Very nice, perfect. All right, let's talk about the cosine function for this angle, negative pi over 6. Cosine is adjacent over hypotenuse, so what are we looking at?
Square root of 3 over 2.
Square root of 3 over 2. Yeah, I can see that. Ow. Anybody else who has a different answer, or are you okay with that? Everybody agreeing that? Positive or negative?
Positive because it's fourth quadrant.
Yeah, because fourth quadrant will be positive x values, negative y values. All right, so let's see, adjacent over hypotenuse, that works out perfectly. Let's talk about tangent for negative pi over 6. So remember, tangent is TOA, opposite over adjacent. And what are we looking at for the tangent function?
Square root of 3.
Yeah, so you will start out with, for the opposite side, it's 1. And adjacent side is square root of 3. Now, let me ask you this, will this be positive or negative? Negative, because even if you think about x and y values, one of those is negative, one of them is positive. But if you also think about tangent being the ratio between sine and cosine, if one of them is negative and the other is positive, your negative sign will stay. So it's actually going to be negative. And then, yeah, rationalizing your denominator will make it negative square root of 3 over 3. Perfect. So we have the 3 main functions. Now let's do their reciprocal. So sine, remember, S goes with C. So cosecant will be the reciprocal for the sine function. So you're literally just inverting the fraction. What will you end up with? Yeah, very nice. Negative 2. You can start out with negative 2 over 1, which basically just becomes negative 2. Cosine starts with a C, so its reciprocal begins with an S, so that will be secant. And what is our secant function going to be? 2 over square root of 3. Rationalize that, and what do we get?
2 square root of Is it,
You're missing something in that.
then you have to multiply get rid of the denominator?
No, you keep the denominator. So what will happen is,
Oh,
kind of trying to do this on the side here. Okay, let me just show you that. So if you have 2 square root of 3 and you're trying to rationalize your denominator, you basically end up multiplying both your numerator and denominator by square root of 3. So that ends up giving you 2 times square root of 3 on the top. On the bottom, since you are doing square root of 3 times square root of 3, it just cleans up into the number 3. So when you rationalize, this will become 2 square root of 3 over 3. Because basically what's happening on the denominator here, you're taking square root of 3, multiplying it to itself. So your square and square root cancel out. And that's how you get a number without any radicals on the denominator. And that's why it's called rationalizing the denominator. All right, guys, so we've got cosecant, secant, the last one is cotangent. And what will cotangent? Oh, yeah, that guy should stay positive. Cotangent will be the reciprocal of the tangent function. So that will give us what? It will be easier to look at the original instead of this, because this you would have to clean up. This one will be easier to work with.
Negative square root of 3.
Yeah, basically negative square root of 3. And then, again, if you wanted to use definitions for these guys, your cosecant would be hypotenuse over the opposite side. Secant would be hypotenuse over the adjacent side. And cotangent, of course, would be adjacent over the opposite side. So you can use those definitions also for finding your functions. Questions? All right, let's save this guy and let's see which one do I want you guys to work on your own. Second, I need to figure out which one you guys can work on your own. Let me see if I can use something that is on the unit circle that you guys can work with. Yeah, you should be able to do that. So let's have you guys do number 18. T equals negative 4 pi over 3. So take a couple minutes, come up with your answers, and then we'll discuss them as a group. If you want to discuss it amongst yourselves to check if you're on the right path, that's fine. But come up with all the 6 functions and let's see what your answers come out to be. So first I would start by, trying to figure out what its degree measurement is, where it falls on the unit circle. So then if you need to have positive, negative signs. Now, obviously, since this is a negative angle, it's going in the clockwise direction also. And again, guys, you're coming up with all 6 functions. when you're drawing your triangles, you want to kind of keep the direction that this would be in. So where is your negative root? This one. So your central angle should be going this, so you should actually have your triangle kind of look like this, because then it's easy to transpose it, right? Because this technically is, yeah, because that corner will be 90, yeah, so that's how you want. Straight line there. And now what will these angle measurements? See, now it'll be easy to do this. Do you guys have a unit circle with you? Did anybody find out? Okay, so can you tell me where your -4π/3 is going to fall? That's kind of. Where is your -4π? Second quadrant, what angle does it correspond to? 120, yeah, because if this is +4π/3, it's negative will fall here, right? So that one, so since that's where the angle falls, when you're drawing this triangle, try to keep that central angle the same. So you want to keep it like this. And keep your triangle open like this here, 90-degree falls here, and then you can see which measurement is used. Because what's your central angle? What's the measurement? 60, are you sure? Central angle is angles that fall here. So for that -4π/3 with the vertical, what's your central angle?
It's not 60.
How are we looking at this?
Because it's.
The exact, yeah, that's what we know.
Sine is 1/3.
Hold on.
The sine.
Is opposite, sorry, cosine is adjacent over, okay, I'm gonna have to draw a triangle, sorry guys, my brain does not work without the visuals. So adjacent. -4π/3. Yeah, if any one of X and Y is negative, your tangent will become negative. Okay, yeah. Now, the answer key is not matching with the answer I'm coming up. Because you said cosine was
Yeah,
-√3/2.
yeah, because adjacent to it is the square root of 3.
Yeah, that's how I have it too. Still trying to think why they're using 60° for the central angle, because I'm not seeing it. And that's kind of what you were talking about, is using 60°. So why are you using 60°?
So,
Are you looking from the horizontal?
yeah, so I just went, so full, 180 degrees, split that up 3 on each side.
Because you're looking like this, so, yeah, that's what I'm thinking. Is what the textbook is doing, and I'm trying to figure out why they're doing. Because if we are doing from the horizontal, it will be 60°. If you do it from the vertical. Yeah, it looks like they're calculating from the horizontal. Let's get back to our textbook handout here for a second. Because that is going to be the big part of deciding what angle you are looking at when you do your reference angle. So going back to this example that we had looked at, which is kind of where we are at, in terms of angles, because you're looking at that negative 4π/3, which brings you into the third quadrant, going in the clockwise direction, which technically is our second quadrant. So you can see over here, when we were trying to find the reference angle, we subtracted 180° from it, which was this distance here, and then that's what gave us the reference angle. So that's the same thing we are going to have to do with our negative 4π/3, because again, your negative 4π/3 corresponds to this angle right here. So you are basically subtracting the 180 from it, which would leave you with this angle over here, which would give you 60°, which means your triangle will end up looking like this from the horizontal. You would have 30° here, 90 here, 60 here, which means opposite would be 1, hypotenuse is 2, and square root. So your central angle would be the 60°. So not from the vertical, as I was thinking initially, it's going to be from the horizontal, which will switch those 30 and 60° angles on you. And then you should be able to come up with your 6 function definitions. And then, of course, based on the quadrant you're in, you decide your positive and negative values. So basically what will happen is, if those of you who had already completed the activity, you will now be switching your sine and cosine values. But that will also affect the remaining 4 functions. All right, so let's take a look at this. Will your sine be a positive or a negative value in quadrant 2?
Positive.
Sine will be positive, cosine will be negative. Okay, so what's your sine function? So if you're going opposite over hypotenuse, what is your sine function? Very good, square root of 3/2. Cosine? Negative 1/2, very good. Tangent? Yeah, so since cosine is negative, your tangent will be negative. So this will be negative opposite over adjacent. So that comes out to be negative square root of 3. All right, let's do the reciprocal function. So sine goes with cosecant. What will your cosecant come out to be?
2 square root of 3/3.
Very good. So you will start out by just inverting 2 over square root of 3 and then rationalize that. Secant will be the reciprocal for cosine, and what will that come out to be?
-2.
Very good, invert that fraction. And then cotangent would be the reciprocal of tangent.
-1 to the square root of 3 to the third derivative.
All right, guys, I do need all of you to participate. Christopher's not the only one in our class. Okay, so like I said, start with the 3 main functions. Once you have those, then of course the remaining 3 become easy because you already have the bases, you're just inverting those. So you've got a bunch of examples on this. You can see there's examples which are of course asking you to find all 6 functions, and you can see there are positive and negative angles. Of course, we stuck to negative angles in both our examples, but you do have more examples that you can kind of work through. Of course, you've got more examples in your handout. So if you look at the lectures online, you will see solutions for these 4. The last part I want to talk about is the domain and period for the 6 functions, but we're just starting out with the sine and cosine functions. So remember in college algebra also, we talk about domain and range for each functions, right? The domain tells you what x values you can use, and the range tells you based on those x values what your y values will come out to be. So these are also functions, so we can definitely define domain and for that matter, even range for these. So you can see we're telling you the domain of sine and cosine functions is the set of all real numbers, which means when you do sine of t, basically you can have no restrictions on what values you can evaluate your sine or cosine functions at. So we're basically saying if you have the set of all real numbers, based on that, your range for these 2 functions will come out looking like this. So they're kind of breaking it down. If you have, there's your sine function. So basically for your sine function, you are going to stay within the values of -1 and 1, and that's for your range. So basically we are saying, remember your sine functions are the y values. So we're basically saying the maximum and the minimum values you're going to get for y is either going to be +1 or -1. For the cosine function, which represents the x value, we're basically saying same thing, but on the x-axis, that your maximum and minimum will be +1 or -1 for the x value. So as far as the t goes, that's your domain. That can be all real numbers. So basically anything from -infinity to +infinity can be your sine of t, but the output you get from the sine of t or the cosine of t is going to be restricted, because cosine is only going to be between -1 and 1, and you can see that's including the endpoints. For the sine of t, same thing on the y-axis is going to be between -1 and 1. And actually when we start graphing both of these, just a regular graph for sine, remember that's that wave kind of look. You will see that your y values will be restricted by +1 on the upper half and -1 on the lower half for both sine and cosine functions. So remember, basically domain for both functions is all real numbers. The range for both functions is going to be between -1 and +1, including the endpoints. The other thing we talk about when we're talking about trigonometric functions is their period. A period basically means it is, like, I want to make sure, I believe the sine function starts at the origin. So the idea is within a period, you should reach a maximum value, you should reach a minimum value and come back to where you started. So that would be, 1 period. So it can be you started from, touching the x-axis. So you started from the intercept, you went to a maximum, you came back to an intercept, you went down to a minimum, and then you came back to an intercept. So if you finish one cycle, basically where you've hit a maximum number, you've hit a minimum number, and you've come back to your starting point, that forms a period. And this will be true for all trigonometric functions, sine, cosine, tangent, and the other reciprocal ones. But, of course, graphs will be different, so periods will be different. So in this case, we're saying if we add 2 pi to each value of t, this will basically result in giving you a complete revolution around a unit circle. And so that means if I take whatever given angle I have and I add a 2 pi, you know, if that was this angle here, I add 2 pi, it gives me a whole revolution and I come back to my starting point, right? If this was my starting angle and I do a 2 pi revolution and I come back to my starting point, and that's going to be true for both sine and cosine functions. So both of them have a period of 2 pi. And remember, we had talked about this when we had talked about coterminal angles. You can keep adding multiples of 2 pi or subtracting multiples of 2 pi, and it still brings you to the coterminal angle. So that's, again, the concept you are falling back on, because I can add 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, doesn't matter, to both my sine and cosine functions. And it's going to keep bringing me back to that same angle where I started out at. So that's going to give you your period for a sine and cosine function. So we're defining it as a function f is periodic when there exists a positive real number c, such that when I add that c to my original angle, it still brings me back to that same number. And that's what happens, right? I add 2 pi to an angle and I still end up at the same angle. So that's what they're talking about in terms of being a periodic function. And you can kind of see some of the other terminologies we are saying. We're basically saying functions that behave in that repetitive or cyclic manner are what we would consider as being periodic. So we're basically saying sine and cosine functions are periodic and they have a period of 2 pi. Your other trigonometric functions are also periodic, but their periods are going to be different because each function will behave a little bit differently. Something else you should recall from your college algebra is when functions are odd and even. So the algebraic definition is if I put a negative number in, but I get the same result as if I had used a positive number, that's when my functions are even. So that's going to only happen with cosine and its reciprocal function, which is the secant. Okay, so cosine and its reciprocal are the only even functions. So basically the idea is if you find cosine of negative pi and cosine of pi, right? One positive, one negative, you're still going to get the same answer. And that's what even functions do. For the odd functions, when you put a negative, it makes your whole answer negative. So if you did sine of negative pi, your answer will then be whatever you got for sine of pi, but now it becomes a negative. So if you just look at sine of pi, you may have had a positive answer, but once you try to do sine of negative pi, it changes that to a negative. So that's what odd functions do, is they will change the sign. So positive will become negative or negative will become positive. And that happens when you have odd functions. So I would again recommend if you guys have, if you're a bit confused about what odd and even functions look like, I would again ask you to go back to chapter P, look through the college algebra concepts to make sure you understand how odd and even functions work. And then we'll pick up from here and do some examples to show you what it would look like once we start evaluating these functions. So at this point, guys, some of you have still not started working on homework. Please start working on homework. You should be able to successfully finish 1.1 and then at least do up until this point in section 1.2. So do not waste this weekend. Get caught up on your homework. As I said in my email that I sent to you guys last night, as soon as we finish section 1.4, we're going to take our exam the very next class. So you're not going to have a big turnaround time between finishing and taking the exam, okay? So please don't fall behind. You need extra help, let me know. Thank you. All right, guys, have a wonderful weekend, I guess. I'll be seeing you on Tuesday. So take care, everyone. Yeah, you too. Thank you.